Hello, everyone, and welcome back to the Freely Nourished podcast, the podcast that teaches you to break the cycle of dieting by teaching you to nourish your body well. I am your host, registered dietitian Erin Casey, owner of New You Nutrition Counseling. And today I want to talk to you a little bit just about scientific research and kind of what it means and what it doesn't. So, if you didn't catch it, last week I did a great breakdown of intermittent fasting. And through it, I kind of talked through some of the more recent scientific studies about intermittent fasting and kind of the conclusions that we can draw from them, and then also some of the things that we cannot draw from them. And in the making of that episode, I saw an opportunity to really kind of break down kind of some of these methodological drawbacks in various scientific studies and kind of how things sometimes get just a little bit, shall we say, elaborated in the public media. And of course, as we've all lived through the last several years of a pandemic, the term like do your own research has become like a household phrase, right? So in kind of my my wants to educate kind of the public on various health and nutrition topics, I think it also is my duty to teach you kind of how to educate yourself, kind of what kind of resources to look at, what to kind of deduce from various things. And also just kind of certain things to look for in terms of kind of like limitations and co-founding factors and things like that. So today I'm going to be walking you through no topic in particular, but just kind of teaching you an overall strategy of like, if you are curious about something, whether it's a diet or honestly, it could be COVID vaccines or, hydration status or fitness, and, anything, most, major fields, particularly in health, but really, most major fields have kind of an accepted way of researching them and kind of publishing that research for the public. So I'm going to walk you through kind of a little bit of what that looks like specifically to nutrition, just because that's my field. But keep in mind, this translates to lots of other non-medical fields as well. So kind of first things first, you want to make sure you know what you're reading. So a lot of times, people look things up via Google, right? That is kind of like our jam. And if it's not Google, it's Bing or Yahoo or like some other major search engine, right? And there's nothing wrong with that. I want to be very clear. Like there's nothing wrong with kind of starting an initial search that way. But I want to be clear that the types of media that are going to come through a major search engine like that, whether it is Google or, like I said, Yahoo, MSN, what's the other one? Bing, anything like that, you are going to get what is called lay media or like popular media. And what that means is that those media sources are written by reporters and journalists. Now, nothing against reporters or journalists, but what they are doing is taking either interviews or firsthand accounts of reading peer-reviewed journals, which I'll talk about what that means in a minute, and they are consolidating it for you. So basically, what you are reading is someone's interpretation, and whether or not that person has the qualifications to make that interpretation is somewhat up for debate, right? Now, that said, all scientific literature is and should be published so that lay people can understand it, right? That our goal is not to kind of live on this like upper echelon cloud of intelligence, and not that people with doctorates are any more intelligent than people without them, but our goal is not to kind of live in this academic kind of different language bubble, right? If we do research, if we spend thousands of dollars, usually taxpayer dollars, on a study, and we cannot convey what that research has said to the taxpayers that pay for it, then we have not done our job. Our job, any scientific journal that you pick up, whether it is your field of expertise or not, you should be able to understand what it is saying. So that said, that goes for reporters and journalists and people of that nature too. They should be able to reasonably read through the paper and understand what it is saying, even if they don't necessarily understand the context or kind of the larger body of research. They should be able to understand what that one study is saying. That said, these people are not experts in this field. And a lot of times they don't understand, they may understand the basic science of kind of how something was done, but they don't maybe understand the caveats of what that means in terms of the interpretation. Now, again, the job is on the original author of the study to claim that, right? It is to claim that, okay, well, this study was done in, for example, mouse models. So we can't just automatically assume that the same is true in the human condition, right? So that's on the author of the original publication to be very clear about that. But then it's also on the reporter to say, this was done in mouse studies. This wasn't done in humans, right? And I think a lot of times some of those like nuances get lost. And I don't think it's necessarily the reporter's fault or the media's fault. I think a lot of times it comes down to deadlines. It comes down to like character or like space limits or like formatting errors and things like that, to where they're maybe not able to kind of as elaborately explain things like they would. But what it does lead to is a lot of misinterpretation, either because it's not explicitly said or it's just not explicitly understood by the person reporting it. So I think that's, and nutrition research gets a lot of flack, and really a lot of scientific research gets a lot of flack because it's like, well, one study said this, and then I read this, and it's kind of like, yes, both of those things are true. There's one study that said this and another study that said that. They're different. We don't know why yet, but that's what we know, right? The goal of scientific data is to inform, at least in the realm of healthcare, is to inform practice, right? But at the end of the day, you can't write a study and say, well, this is what our data showed, and this is what we think it should mean. You have to say like, no, this is what our data showed, and this is what we know, and this is what we don't know. And this is probably the next experiment we're going to set up to try to figure that out. So a lot of times I will use cholesterol in eggs, for example. We've seen studies that people who ate more eggs had higher cholesterol, and we've seen studies that people who had more eggs didn't eat or didn't have higher cholesterol. The difference that we probably didn't account for was fiber intake, right? So we now know that activity level and fiber intake, as well as genetics, largely are what drives your cholesterol values, not your intake of cholesterol. But in the one study, that hallmark study, they didn't account for any of that. So basically what ended up happening is a lot of the people in the high egg eating group also weren't active, also didn't eat a lot of fruits and vegetables. So that's why that effect went away when we controlled for that later on. So that's just one example. But I want to be kind of, clear again, that if you are typing something into a just massive search engine, what you are getting is a lay person's interpretation of probably one or two studies, not a huge body of evidence, because again, they're on a deadline. They have, and I'll be honest too, the media is looking for a story. They're looking to draw readers in. If they have one study that shows shows that, I don't know, keto is good for weight loss, and then like 5 studies that show that, well, it's good for weight loss, but it's bad for like these other 4 things, they're gonna be like, well, people want to lose weight, and that's what readers are going to be wanting to look at. And like, that's the study they're going to summarize. They're going to ignore the rest of it. And as they're allowed to do, their goal is not, to an extent, it should be to inform the public, but that's not always, as we know, what happens in practice. So I just want to be clear. And again, they're a lay person. They don't necessarily have the background to fully break down the information they're presenting to you, because it's just not their area of expertise. That said, you can, in fact, do your own research. So, you can't conduct your own research studies. That's not what I mean. But you can play reporter, right? You can go and look into the scientific data yourself and tell yourself, okay, read those studies yourselves. And 2 really good resources to do that are Google Scholar, which is basically Google. And you can type in, just www.scholar.google.com, or in a Google search box, you just type in Google Scholar and it pops up. That is basically a Google for what are called peer-reviewed journals. And what peer-reviewed research means is that it's a research study that was done by a group of people who are presumably experts in that field. But then their study was done and then it was published. But then people who are also experts in that field had to review what they had done. So basically it's a checks and balances system. It's basically saying, okay, you did this study, you said you got these results, but in terms of why that was done, what it means, things like that, other experts in their field have to agree to that. Excuse me. So that's not to say that, there are opinion pieces and things like that as well, which are not necessarily peer reviewed. But in terms of like the methods used, the conclusions drawn from those methods, whether or not the data is believable or presented in a like an accurate way, those things are all reviewed by other experts in the field. So that's where you would get things. Google Scholar is one place to find those. PubMed is another. So like I said, most of these studies are often funded by organizations like the National Institutes of Health, at least in the case of healthcare, which is a government funded agency by tax dollars, right? So because it is funded by tax dollars, we owe it to the public to then, be transparent in terms of the research and the data that we are producing. So PubMed is where you get any NIH funded study. I will say that these are published in what are called academic journals, these peer-reviewed articles. So some of those you do have to pay for a subscription to access the article. That said, that's to access the full article. You should be able to access the abstract, which is basically just kind of like the Cliff Notes version of it for free, either on Google Scholar or on PubMed. So you may not have to be able to get access to the full article, or you may have to pay for that. But and there's open access journals that are free to everybody, but you should be able to get access to that abstract for free no matter what. And that gives you kind of a rough idea. And then, to that end, bigger institutions like hospitals, certainly academia, even, kind of bigger corporations, a lot of times they will pay for journal access for certain things. It just kind of depends on the field and whether or not that type of information is pertinent to you. So you may be able to get access through various other ways too. But anyway, that's where you find the actual peer-reviewed article. So that's how you kind of play reporter on your own and read through the studies yourself. A couple of things when you are reading through these studies, kind of assuming that you don't have a background in health or in clinical research, and you're kind of like, okay, like I read this study, it sounds great, but like, what does it mean? Particularly in nutrition research. And I will say that I'm very much focusing on nutrition research here. Things to think about are, what model system were they, when you look at how the study was done. So studies are typically broken down into the abstracts, just kind of a summary paragraph at the top. Then there's an introduction that talks about kind of a little bit of background information about the topic at hand and why this particular study that they're going to talk about is relevant. And then there's their methods, which is basically telling you exactly what they did. There's their results, which is kind of just the raw data of like, numbers and statistics and things like that of what the study actually showed. And then there's like a discussion or a conclusion section that basically talks about what they think that those results mean in the grander kind of scope of the field. So I would say, if you're going to pay attention to anything, kind of the key part to pay attention to is the methods, and kind of just so that you know what you're actually looking at. I talked about this a lot in the intermittent fasting podcast, but a lot of clinical research before it goes into humans and things like that is done in animals or even in cell models. And there's just a lot of nuance in terms of what you can claim from animal models and what you can't. So for example, if you have, let's say you're doing an intermittent fasting study on rats, right? Well, there's going to be presumably your control group of rats that are not under this intermittent fasting regimen, and then your intervention group of rats that are following an intermittent fasting regimen. Well, but all of those rats live in the same house, right? So they are all living in the same types of cages, the same access to water, same access to sunlight and things like that, same temperature, all of that kind of stuff, same access to handlers and all of that kind of thing. So like there's a very, very controlled environment that whereas when you try to take that same type of study and do it in people, these people are living in different houses, they're working different jobs, they may or may not have kids, and their family life may look different, they may have different exposures to environmental toxins, like all of this stuff is suddenly different. So what we see in animals, while it definitely can give us clues as to what may happen in humans, it's not always just kind of a direct translation. There's always just going to be more variability in humans that we can't control for, particularly when it comes to nutrition, but with other health metrics as well. So that's kind of something to kind of think about as well. Particularly with the intermittent fasting research, but also with like a lot of the other diets like keto and stuff like that. Like a lot of the health claims come from animal studies, and that translates into the popular media. And it's just kind of like, it was in a mouse study, but the headline will read, oh, intermittent fasting, reduces A1C by such and such. They never at any point there make it clear that that was done in rats and not human beings. Or maybe it's in some kind of fine print throughout the article, but people may or may not even read that far into the article. But again, media is trying to do that attention grabbing header. Maybe not the most ethical practice, but that's a discussion for another day. So definitely pay attention to the methods, whether it was in humans, rats, cells, etc. And then if it was in humans in particular, if it was in rats too, but obviously it's a lot easier to do animal studies than it is to do human studies. But so if it's in humans, pay attention to the number of participants. This became a big thing with the clinical trials for the COVID vaccines, right? People kind of, insisting that these things weren't safe. A standard issue clinical trial for most medications to get approved is going to have somewhere from like 2 to 5,000 participants. Ironically enough, I know at least the Pfizer vaccine, I'm not sure about Moderna, they had over 40,000 participants. People were still questioning. Which is kind of ironic and sad if you ask me. But again, there are a lot of studies out there that have, far less than that, order of like 30 to 50 people, which is informative, right? Those are still worthwhile studies to do, but also kind of keep in mind that that's a very small population. Those people are probably pretty similar because they're probably from the same area. So things like demographics, socioeconomic status, travel, jobs, things like that. Like they have to be able to travel for a study. They have to have the time to participate in a study. And they're also like willing for whatever reason to adhere to these, dietary restrictions being done in the study. So you kind of have to kind of build your mind a picture of what kind of person that is. That's not everybody. Right. So I think it's just kind of important. And again, if it's not everybody, then it kind of is like, well, like what about other, ethnicities or like people who work different types of jobs or like whatever, like there's just different factors that are not accounted for. And then there's not a lot of them, right? So it's just kind of, it's a clue, but it is by no means. So again, like a lay media person may put, intermittent fasting reduces A1C. This time it is in humans, but it was only in 30 humans. And like the differences weren't that big, and things of that nature. And then of course, how many people you have in your study also increases your statistical power. So it kind of just basically, makes those results more meaningful. Another thing that, kind of will increase that statistical power is whether this trial is randomized, which means that, let's say you have 100 people, you have to randomly assign them to groups. You can't just say, oh, you'd be a good person for this group and you would be a good person for that group. That's not how it works, right? They should be randomized, and whether or not it's controlled, right? So a lot of times what some of these studies will do is they take one group of people, just one group, and they say, okay, let's follow these people on a keto diet for 3 months, for example. And then, in those same people, they see a reduction in A1C. Well, okay, that's helpful, but we also don't have a control group that shows that like that doesn't happen if they're not on a keto diet, right? If they're on some other type of diet, for example, or like they just lost weight or whatever, right? Like we just don't know. So having a randomized and a control group, again, there are reasons why people don't, money, access to participants and things like that, time. There might be reasons why they don't. And again, those studies are still valuable, right? It's still informative, but it's also, again, it's just a clue. It's not grounds for, well, that means keto is the best thing ever and everybody should do it, right? So I think that's kind of just some things to keep in mind. Also keep in mind when you are looking at their methods, how long was the study done? Most nutritional studies do not exceed 3 months. That is different amongst different disease states and different healthcare, practices and whatnot. But for nutrition, 3 months is the max. And in fact, studies that do like maybe a 3-month outcome and then a 6-month outcome, a lot of times they see like, okay, the people start here, what we call baseline or the start. They see their maximal effect up here, whatever that is. That could be weight loss, that could be A1C, blood sugar, lipid panels, whatever. They see their maximal effect at 3 months. And then by 6 months, they're starting to drop back down. My question then becomes, well, what happens if we get to 12 months? What happens if we get to 24 months? Like fixing somebody's A1C at a random 3-month time point does nothing for their overall health. So is this diet really effective? That kind of becomes my question then. So again, pay attention to how long. I guarantee you're not going to find much in the world of nutrition that extends beyond 3 months. And that's because dropout rates are high. People don't adhere to the diet. And it's costly to run some of these studies too. So sometimes there's a practical barrier there too. But again, keep in mind, what does this tell you? Right? That, at 3 months, yeah, keto drops your A1C. That's great. But can you continue that for 6 months? Can you continue that for a year? Can you continue that for 2, 3, 5, 6 years? If the answer is no, then probably that effect is going to go away. And you're going to be right back where you started. And that's the uncomfortable part that people don't like to talk about with nutrition research. So I think that's something to kind of consider as well. All of those factors, right? So the number of participants, whether it's randomized, whether or not it's controlled, and how long it was run, all of that affects the statistical power and kind of the types of conclusions you can draw from it. So obviously, the more people you have, if there's a control group, and if those control groups are randomized, basically you have a lot more statistical power to say that any differences you see between your groups are because of your intervention. Right. So like I said, if you have a group of people and you just follow them on keto for 3 months, you have really very little grounds to say that your intervention of a keto diet is what caused that, because you don't have an alternative. If you have a group of people that did keto for 3 months and their A1C dropped, and then a group of people who did not do keto and their A1C did not drop, well, now we have some standing room to say, hey, look, we took 2 groups of people, we treated them the exact same with the exception of this intervention. And we saw this result in the intervention group, and that result was not seen in the weight loss group or in the control group. So that's just kind of things to think about. If your groups are randomized, and this gets into kind of like weird statisticalness, but that power increases. So basically you're looking for kind of increased significance, and the number of people you have in either group, that also increases your statistical power as well. To that end, if you're looking into hard data and that's just kind of not your thing, or you're not quite sure kind of like what that means for you, there are kind of some other types of websites that you can look at to kind of see what is a more expert opinion, not just kind of the media's opinion. So kind of taking away that factor of kind of trying to do the attention grabbing headlines, kind of just utilizing like, okay, what does the science say? What does this mean for me, the person? Organizations that have like a .org, a .edu, or a .gov address tend to be more balanced. So again, they're not like being paid by media companies to draw in readers or subscribers or anything like that. So all of that is gone. They're usually providers of some sort. So like a physician, sometimes they're researchers, but generally speaking, they're more grounded sources. And then of course, when in doubt, ask an expert that you trust. So that can be your dietitian, that could be me, that could be your healthcare provider. But but your sister's cousin who did keto and lost 50 pounds, like that's not a reliable source. Ask your doctor. Ask multiple doctors, ask a dietitian, ask the questions that you want to ask, not just like, is this going to work? Because the doctor's reading the same study you are that says keto makes people lose weight in a 3-month time span, and be like, well, what do we know about keto in the long term? Are there downsides? Are there adverse health effects? Is it sustainable long term? Is it smart to do it long term? Those kinds of questions that kind of affect how how this data is going to make change implications for your life. So those are just some tips on things that you can do to kind of do your own research and do it well. And I hope that you found it informative. If you have any questions, by all means, leave me comments. Hit like and subscribe if you found this content helpful. If there are, as I mentioned, I think is the last video right before this one is it broke down intermittent fasting. If you would like to see me do that with other diets such as keto, by all means, leave me a comment. I'll gladly dive into the research for you. But yeah, I hope you all have a wonderful rest of your day and best of luck on your nutrition journey.